Good morning everyone. This is Deepanshi from BSc Chemistry Honors second year. Today I am going to present a presentation of inorganic chemistry. The topic of today's presentation is acid and bases. HSAB concept, hard and soft acid base concept. Acid, shortest, turn blue litmus red, having ability to dissolve substance insoluble in water on reaction with certain metal give hydrogen gas. Bases, they are bitter in taste, turn red litmus blue, neutralize acid. Now, what is Arrhenius concept? Arrhenius acid. According to this, acid are those substances which dissociate in water to give hydrogen ion, that is H positive ion. HCl give H positive plus Cl negative ion on dissolving in water. Similarly, HNO3 when dissolved in water give H positive plus NO3 negative ion. CH3COOH give CH3COO negative ion plus H positive in dissolved in water. In generally form we say HA is acid when dissolved in water give H positive and A negative. Now, what is Arrhenius base? Bases are those substances which dissociate in water to give hydroxyl ion. NaOH give Na positive, OH negative. NH4OH dissociate into NH4 positive and OH negative ion. CaOH twice when dissolved in water give Ca2 positive plus 2OH negative ions. In general, we say BOH gives B positive plus OH negative in aqueous medium. Note, acid give H positive ion, base give OH negative ion in water. Important point, polyprotic acid, acid like H2SO4, H3PO4, etc., which contain two or more insoluble hydrogen atom can dissociate in more than one stage, giving H positive ion. In each case, these are called polyprotic acid. For example, when H2SO4 dissociates in water, they give H positive plus SSO4 negative. Again, HSO4 again dissolve in water and give H positive plus SO4 2 negative ion. Or we can simply say H2SO4 when dissolved in water give 2 hydrogen ion plus SO4 2 negative ions. Now, the strength of acid or base depend upon the capacity of ionization to H positive or OH negative ion respectively. Here, strong acid and strong weak bases. Acid such as HCl, HNO3, H2SO4, which are almost completely ionized in aqueous solution, are called strong acid, while acids such as CH3COOH, HCN, H3PO4, H2CO3, which are weakly ionized in aqueous solution, are called weak acid. Now, strong bases or weak bases. Bases such as NaOH, KOH, etc., which are almostly completely ionized in aqueous solution, are called strong bases, while bases such as NH4OH, CaOH twice, AlOH thrice, etc., which are only slightly ionized in aqueous solution, are called weak bases. Now, what are the limitations of Arrhenius concept? According to Arrhenius concept, an acid must contain hydrogen and a base contain hydroxide group. However, there are large number of substances like NH3, CaO, N2CO3 which are known to be basic but don't contain hydroxyl group. Similarly, these are substances such as CO2, SO2, SO3 which do not completely contain hydrogen, but even these act as the acid in aqueous solution. Now, this concept of acid and base applicable only in aqueous solution, but fail to explain the acid-base behavior in non-aqueous medium. such as liquid ammonia, sulfur dioxide, alcohol, etc. Now, Arrhenius concept is also failed to explain the reaction between acid and base in the presence of water. In the absence of water. Now, Bronsted-Lowry concept. Bronsted-Lowry concept. According to this concept, an acid is a substance which can donate photon, whereas a base is a substance which can accept a photon. For example, when HCl plus NH3 give NH4 and Cl negative ion. Similarly, HCl plus H2O give H3 positive ion plus Cl negative ion. NH4 positive plus H2O give H3O positive plus NH3. Note, the acid-base reaction are also regarded as photon transfer reaction. There are certain substances such as H2O, H3O3, H2SO4 which have capability of donating as well as accepting the photon. So these are known as amphoteric substance. Example, water. Water has act as acid as well as a base. For example, HCl plus H2O form H3O positive plus Cl negative. Here water is act as a base. Now, as an acid, H2O plus NH3 form NH4 positive plus OH negative. Here, water is act as a acid. Now, the next topic is conjugate acid base pair. HCl रिएक्ट करता है NH3 के साथ और देता और NH4 पॉजिटिव एंड Cl नेगेटिव आयन हमें मिलते हैं. तो एसिड lose a photon and form a conjugate base. Similarly, acid gain photon and form a conjugate acid. So, base formed from a base is referred as conjugate base of the acid. Similarly, the acid formed from a base is referred as conjugate base acid of the base. जो Cl negative ion here, it is the conjugate base of HCl, whereas NH4 positive is the conjugate acid of NH3. Acid give conjugate base plus H positive ion. Here also base plus H positive ion or a photon give a conjugate acid. Here are some examples. Now we are discussing about relative strength of conjugate acid and base. HCl is a strong acid. When react with H2O, it gives H3O positive plus Cl negative ion, which is a weak base. Means conjugate base of strong acid is weak. Second, CH3COOH. It is a weak base. When it reacts with H2O, it dissociates into H3O positive in aqueous medium plus CH3COO negative. It is a strong base. The conjugate base of weak acid is strong. Third, CH3COO aqueous plus H3O positive gives CH3COOH plus H2O. There is a strong base here. क्या strong base give weak conjugate acid base. Similarly, when a weak base, that is Cl negative plus H3O positive aqueous give HCl, it is a strong acid plus H2O. Conjugate acid of weak base is strong. Now, advantages of Bronsted-Lowry concept over Arrhenius concept. It can explain the basic character of substance like Na2CO3, NH3, etc., which do not contain OH group, hence were not base according to the Arrhenius concept on the basis of that they accept photon. Second, this concept is not limited to molecule but also cover even the ionic species to act as acid or base. It can act as acid base reaction. It can explain acid base reaction in the non aqueous also. Now, there are some limitations of Bronsted-Lowry concept. First is it can explain the reaction between acidic oxide like CO2, SO2, SO3 and basic oxide like CaO, BaO, MgO, etc. which take place even in the absence of solvent. Example, CaO plus SO3 gives CaSO4. Now substance like BF3, AlCl3, BeCl3, etc. are also behave as acid, but they don't have photon to donate. So today we firstly discuss about acid and base. Now then Arrhenius concept, then Bronsted-Lowry concept. That is enough for today. Thank you.